You're scrolling through your feed on a seemingly ordinary Friday, October 24th, 2025. Between the memes and the news, a headline flashes by: dry and bureaucratic. International Asteroid Warning Network announces astrometry campaign for Comet 3I/Atlas. Most people thumb right past it. But if you knew what to look for, that headline was a 5-alarm fire disguised as a press release. Because on that same morning, at 0700 Universal Time, the world's invisible shields twitched. Deep space infrared sensors, designed to track ballistic missiles and rival satellites, subtly pivoted. High-gain radar arrays, whose usual business is cataloging space debris, recalibrated their focus. Classified protocols, known only by alphanumeric codes in secure briefing rooms, were quietly activated. The trigger? Comet. Or at least that's what they told us. NASA's statement, issued 6 hours later, was a masterpiece of reassurance. No threat to Earth, repeated like a mantra by every official spokesperson. Dr. Lindley Johnson, NASA's planetary defense officer, patiently explained that 3I/Atlas would pass at a safe distance of 1.8 astronomical units. That's 168 million miles away. For perspective, our moon is only 240,000 miles away. This isn't a close shave. It's a distant nod from across a crowded room. So why the military-grade response? The International Asteroid Warning Network, IAWN, exists for one reason: to stop rocks from hitting us. It's a planetary insurance policy. They don't typically mobilize for scientific opportunities passing safely in the void. They mobilize for potential city killers, for civilization enders. Yet, here they were launching a 2-month, round-the-clock global observation campaign for an object that, by all official accounts, poses zero danger. This isn't just a few astronomers pointing their telescopes. This is a coordinated, registered, and formalized operation involving observatories on 6 continents. They're asking for continuous coverage, meaning at any given moment, day or night, a professional-grade lens is trained on 3I/Atlas. They've scheduled workshops with undisclosed locations and emphasized rigorous data calibration and rapid sharing. These are the signatures of an organization that needs answers fast and can't afford to be wrong. Anonymous sources within defense circles have described it as a precautionary reorientation. Another called it protocol compliance. But one source, more bluntly, said it felt like the scramble before the 2008 TC3 impact, when agencies had just 19 hours to confirm an asteroid was going to hit Sudan. Except this time, there's no impact, no countdown, no city in the crosshairs. We are witnessing step 4 of a planetary defense emergency playbook, but without steps 1 through 3. The trajectory is clear. The distance is safe. So what exactly are they trying to narrow in on? The only logical conclusion is that the threat isn't about where 3I/Atlas is going, but what it is. To understand the panic, you have to look at the target. 3I/Atlas wasn't just another dirty snowball. Discovered on July 1st, 2025, by the Atlas survey in Chile, its interstellar origin was confirmed within days. It's the 3rd such visitor ever detected, after Oumuamua and Borisov. But that's where the normality ends. First, its path is a little too perfect. It's screaming into our solar system at 61 kilometers per second, and its trajectory brings it within about 5 degrees of the ecliptic plane, the flat disk where all the planets orbit. Think of the solar system as a giant dartboard. The planets are all clustered on the bullseye. For an object arriving from a random direction in interstellar space, the odds of hitting that specific band are low. It's possible, but it feels deliberate. Then there's the activity. Comets are supposed to be dormant until the sun's warmth wakes them up. But 3I/Atlas started vomiting water vapor at a staggering rate of 40 kilograms per second when it was still beyond Mars' orbit, in a deep freeze where most comets are still asleep. The Sun was a distant, weak star at that point. What was driving this intense outgassing? The James Webb Space Telescope provided the next bombshell. Its spectroscopic analysis in late September revealed a composition that made astronomers double-check their data. The ratio of carbon dioxide to water was an unprecedented 8:1. Most comets are water-dominated. This one was a carbon dioxide freak, suggesting it formed in a strange alien nursery around another star, a place nothing like our own. Polarimetry readings from the Very Large Telescope added the term extreme negative polarization to the conversation. In simple terms, the way light scattered off the comet's dust coma was unlike anything in our databases. The dust particles weren't normal cometary dust. They had weird shapes or were made of something exotic, possibly metallic or complex carbon compounds. But the crown jewel of the weirdness, the detail that separates 3I/Atlas from every other comet ever studied, is the nickel. In mid-October, the Keck Observatory in Hawaii detected the clear, sharp emission lines of neutral nickel atoms in the comet's coma. That's bizarre enough. Metals don't just vaporize out of comets like that. But the real shock was what Keck didn't find. Iron. In our universe, nickel and iron are cosmic siblings. They are forged together in the hearts of dying stars. They condense together in planetary disks, and they are found together in every single meteorite, asteroid, and natural space sample we've ever laid hands on. The cosmic ratio is about 18 parts iron to 1 part nickel. You simply do not find one without the other. Yet 3I/Atlas was doing exactly that. It was emitting nickel at a rate of 4.6 grams per second, with iron below detectable limits. This isn't just unusual. It's a chemical impossibility under natural models. As one spectroscopist grimly noted, this observation doesn't align with our understanding of how comets work. It mirrors instead the outcome of industrial refinement processes. To understand the panic, you have to look at the target. 3I/Atlas wasn't just another dirty snowball. Discovered on July 1, 2025, by the Atlas survey in Chile, its interstellar origin was confirmed within days. It's the third such visitor ever detected, after Oumuamua and Borisov. But that's where the normality ends. First, its path is a little too perfect. It's screaming into our solar system at 61 kilometers per second, and its trajectory brings it within about 5 degrees of the ecliptic plane, the flat disk where all the planets orbit. Think of the solar system as a giant dartboard. The planets are all clustered on the bullseye. For an object arriving from a random direction in interstellar space, the odds of hitting that specific band are low. It's possible, but it feels deliberate. Then there's the activity. Comets are supposed to be dormant until the sun's warmth wakes them up. But 3I/Atlas started vomiting water vapor at a staggering rate of 40 kilograms per second when it was still beyond Mars' orbit, in a deep freeze where most comets are still asleep. The Sun was a distant, weak star at that point. What was driving this intense outgassing? The James Webb Space Telescope provided the next bombshell. Its spectroscopic analysis in late September revealed a composition that made astronomers double-check their data. The ratio of carbon dioxide to water was an unprecedented 8:1. Most comets are water-dominated. This one was a carbon dioxide freak, suggesting it formed in a strange alien nursery around another star, a place nothing like our own. Polarimetry readings from the Very Large Telescope added the term extreme negative polarization to the conversation. In simple terms, the way light scattered off the comet's dust coma was unlike anything in our databases. The dust particles weren't normal cometary dust. They had weird shapes or were made of something exotic, possibly metallic or complex carbon compounds. But the crown jewel of the weirdness, the detail that separates 3I/Atlas from every other comet ever studied, is the nickel. In mid-October, the Keck Observatory in Hawaii detected the clear, sharp emission lines of neutral nickel atoms in the comet's coma. That's bizarre enough. Metals don't just vaporize out of comets like that. But the real shock was what Keck didn't find: iron. In our universe, nickel and iron are cosmic siblings. They are forged together in the hearts of dying stars. They condense together in planetary disks, and they are found together in every single meteorite, asteroid, and natural space sample we've ever laid hands on. The cosmic ratio is about 18 parts iron to 1 part nickel. You simply do not find one without the other. Yet 3I/Atlas was doing exactly that. It was emitting nickel at a rate of 4.6 grams per second, with iron below detectable limits. This isn't just unusual. It's a chemical impossibility under natural models. As one spectroscopist grimly noted, this observation doesn't align with our understanding of how comets work. It mirrors instead the outcome of industrial refinement processes. So how do you get pure nickel in space? On Earth, we have a process. It's called the Mon process, developed in the 1890s. Here's how it works. You take impure nickel ore, which contains iron, and expose it to carbon monoxide gas at a specific, relatively low temperature, 50 to 80 degrees Celsius. At this temperature, nickel reacts with the CO to form nickel carbonyl, a volatile gas. Iron does not react. You then pipe this gas away and heat it to a higher temperature, 200 to 250 degrees Celsius, where it decomposes back into pure, 99.99% nickel metal. This is a controlled industrial refinery process. It does not happen in nature. Now back to 3I/Atlas. We know it's producing significant amounts of carbon monoxide. We know a comet's nucleus can have wildly varying temperatures, with some patches heating up while others remain frozen. Is it possible that somewhere on or near the surface of this interstellar object, the precise conditions of temperature, pressure, and CO concentration align to run a natural accidental Mon process? If so, nickel from dust grains could form volatile nickel carbonyl, which would immediately vaporize into the coma. Once in the sunlight, UV radiation would break the compound apart, releasing the pure nickel atoms that Keck saw fluorescing. The iron, left behind, would remain trapped in the nucleus. The implications are staggering. What landed in Mars's vicinity, and what our robots may soon be digging up, wasn't just nickel. It was refined nickel product. Whether through a freakish cosmic accident or something else, 3I/Atlas was functionally identical to an interstellar refinery, spewing purified metal into the void. This is the point where the conversation becomes profoundly uncomfortable. When natural explanations require increasingly contrived and convoluted assumptions, the scientific method demands we consider other possibilities. Dr. Avi Loeb, the Harvard astronomer famous for his Oumuamua hypothesis, has been vocal. We must keep non-natural explanations on the table. He's not saying it's definitely a spaceship. He's saying we should have the courage to ask the question and design observations to test it. The official story is that 3I/Atlas is a harmless, if weird, comet. But the data paints a portrait of an object that is anomalous in its trajectory, its composition, its dust, and its fundamental chemistry. It's not just one red flag. It's a parade of them. And when you see that many flags, you don't just assume it's a celebration. You start to wonder if you're being warned. This brings us back to the massive, coordinated response. If this is just a comet, why the radio silence? Why the gaps in public data? The Minor Planet Center's orbital elements for 3I/Atlas have been fluctuating more than usual. The error bars on its non-gravitational acceleration, the tiny pushes from outgassing, keep changing. JWST's data on the strange CO2 ratio took weeks to be released, longer than usual for exciting findings. This delay isn't necessarily a conspiracy. It's often procedure. Data from major telescopes often has a proprietary period where the discovering team gets first dibs. But in a case with such high public interest and potential implications, that opacity fuels speculation. The phrase "no threat to Earth" is technically accurate. But notice its specificity. It doesn't say no threat to our satellites, or no risk of anomalous emissions, or no possibility of it being anything other than a rock. The assurance is narrow, legalistic, and carefully crafted. Meanwhile, reports from outlets like the New York Post, citing unnamed sources, claim that an interplanetary defense system has been deployed. They mention protocols with names like IPD-9 governing responses to anomalous deep space objects. The language is that of mobilization, not curiosity. The most plausible explanation that ties all this together is that 3I/Atlas is being used as a live-fire drill. Planetary defense has matured. We've built this global shield of sensors and protocols. You don't wait for a real asteroid to see if it works. You test it. And what better test case than a real, physical object that is profoundly anomalous yet poses no kinetic threat? We stand at a threshold. 3I/Atlas, this tumbling enigma from the void, is more than a scientific curiosity. It is a mirror. It reflects our readiness, our fears, and our transition from a species that merely observes the cosmos to one that actively defends itself from it. The Great Filter theory asks why we don't see other intelligent life in the universe. One answer is that civilizations don't survive the transition to becoming spacefaring. They are destroyed by external threats or by their own paranoia. 3I/Atlas is a test of that filter. It's a pop quiz from the cosmos. Our response, global, militarized, and shrouded in secrecy, shows that we have chosen a path of caution, of defense, of viewing the unknown through a lens of potential threat. We have built a deep space firewall, and 3I/Atlas was its first major alert. Whether this object is a natural miracle or something more, it has already changed us. It has revealed that the shield is up, the sensors are active, and the protocols are in place. The universe has sent a messenger. We may never fully decode its message, but our reaction to its arrival tells us everything about who we are and who we are becoming. A civilization that has looked into the darkness and decided to prepare for war, just in case the darkness is looking back. To truly grasp the significance of the response to 3I/Atlas, we must rewind to 2017 and the ghost that still haunts the halls of astronomy. Oumuamua. Discovered by the Pan-STARRS telescope in Hawaii, Oumuamua was the first confirmed interstellar visitor. It was immediately anomalous. Its shape, inferred from its wild brightness variations, was extreme, possibly 10 times longer than it was wide, like a cosmic cigar or a pancake. It showed no visible coma or tail, the classic features of a comet. It was just a dark, tumbling rock. Then came the real puzzle. As it departed our solar system, astronomers tracking its path noticed a slight but undeniable acceleration. It wasn't following a path dictated by gravity alone. Comets do this through outgassing, jets of gas acting like tiny thrusters. But Oumuamua showed no signs of outgassing. Nothing was visible. So what gave it the push? The scientific community scrambled for natural explanations. Maybe it was outgassing hydrogen, which would be invisible to our instruments. Maybe it was a chunk of solid nitrogen, sheared off a Pluto-like world. But each explanation felt like forcing a square peg into a round hole. Dr. Avi Loeb offered a more provocative hypothesis. Perhaps the acceleration was due to solar radiation pressure. And what kind of object is thin, light, and large enough to be pushed by sunlight? A light sail, an artifact of technology. The establishment largely recoiled. The alien probe theory was relegated to tabloids and late-night talk shows. But the mystery was never solved. Oumuamua faded into the darkness, leaving behind a legacy of unanswered questions and a deep-seated unease among astronomers. They had been handed a data set that defied easy classification, and the most prestigious institutions had chosen the comfort of incomplete natural models over the discomfort of a paradigm-shattering possibility. Then came 2I/Borisov in 2019. It was a relief, A textbook comet with a glorious tail, behaving exactly as a dirty snowball should. It was strange only in its origin. Borisov reassured everyone that Oumuamua was the outlier. The universe wasn't that weird. Now, we have 3I/Atlas. And it's not an outlier like Oumuamua. It's an outlier in its own, even more complex way. It has a coma and tail, so it's active. But its activity is wrong. Its composition is wrong. Its chemistry is wrong. The pattern is clear. Interstellar space is not sending us uniform visitors. It is sending us a catalog of the strange, each object challenging our models in unique ways. The response to 3I/Atlas is the direct result of the Oumuamua experience. The scientific and defense communities were caught flat-footed then. They are determined not to be again. The massive pre-perihelion mobilization for 3I/Atlas is the institutional embodiment of a lesson learned. When the next one comes, we will be ready. We will point everything we have at it. We will not let the data slip away. And perhaps we will be brave enough to follow the evidence wherever it leads, even if the path is one we never imagined walking. While optical and radio telescopes have been tracking 3I/Atlas, a quiet revolution has been brewing in the background, one that promises to render our current instruments obsolete. In late 2024, reports began to surface from China about a prototype quantum telescope known as Qianlong-1 achieving first light. The principles are fiendishly complex, rooted in the bizarre world of quantum mechanics. In essence, such a telescope would use quantum entanglement, the spooky action at a distance that so troubled Einstein, to achieve a level of resolution and sensitivity that shatters the limits of classical optics. Imagine being able to see not just the fuzzy glow of 3I/Atlas's coma, but to resolve individual surface features on its nucleus. To distinguish between the jagged topography of a natural rock and the smooth, geometric planes of a manufactured object. To detect not just the presence of nickel, but to map its distribution, to see if it's scattered randomly or concentrated in patterns suggestive of structural components. This is the promise of quantum astronomy. It transforms observation into interrogation. The connection to 3I/Atlas is speculative but electrifying. What if some of the more confident and cryptic internal assessments about the object's nature are based not on public data, but on findings from a clandestine quantum observatory? It would explain the gap between the cautious public statements and the decisive, high-level mobilization. It would mean that someone, somewhere, might already be looking at this comet with a clarity the rest of us cannot conceive. If true, it creates a terrifying asymmetry. The nation or entity that masters quantum sensing first will hold an insurmountable advantage in deep space awareness. They will be able to characterize asteroids, satellites, and interstellar visitors with godlike precision, while others stare through a frosted glass. The race for quantum dominance in space is not a future conflict. It is the new, silent front in the militarization of the final frontier, and 3I/Atlas may be its first real-world target. Adding another layer to this story is the rise of artificial intelligence in astronomy. In early 2025, a neural network developed by a joint JPL-ESA team did something that sent a chill down the spines of those briefed on it. It predicted a specific outburst of activity from 3I/Atlas 72 hours before it occurred. This wasn't a vague horoscope. The AI, trained on decades of data from thousands of comets, flagged an anomaly in the subtle noise-level fluctuations of the comet's light curve. It calculated with 87% confidence that a significant brightness spike and volatile release was imminent. The alert was distributed to scientific teams and, notably, to a classified defense liaison office. 68 hours later, right on schedule, 3I/Atlas flared exactly as predicted. This event represents a fundamental shift from reactive observation to predictive monitoring. The AI doesn't have a theory. It recognizes patterns invisible to the human eye. The deeply unsettling question is, What patterns is it recognizing in 3I/Atlas? Is the comet's behavior just a complex but natural combination of variables the AI has learned to correlate? Or is the AI, in its cold, mathematical way, detecting the subtle signatures of something that is not behaving like a natural comet? The opaque box nature of neural networks means we get the prediction but not the reasoning. This creates a profound policy dilemma. If an AI with a 99% confidence rating predicts that 3I/Atlas will execute a non-gravitational maneuver that has no cometary explanation, does that constitute a threat? Do we act on an algorithm's suspicion? Who gets to make that call? The scientists who built the AI, or the generals who see it as an early warning system? The data from these AI predictions is likely among the most closely guarded secrets surrounding this object. It represents a future where our first contact with the unknown may not be a signal we detect, but an alert generated by a machine that has already decided something is out of place. We are left, then, with a mosaic of mysteries, an object that defies natural chemistry, a global response that mimics a planetary defense emergency, revolutionary new sensors that may be seeing what we cannot, and artificial intelligence acting as a digital oracle. The official story remains, no threat to Earth, and they are almost certainly right in the narrowest sense. 3I/Atlas is not going to crash into our planet. But the question was never just about impact. The question is about discovery. Are we staring at the most bizarre natural object ever found, a 1 in a trillion cosmic fluke that is teaching us how little we know about planet formation in other star systems? Or are we witnessing something else entirely, the passive, perhaps derelict artifact of a technology not our own? The truth is, we may never get a definitive answer from 3I/Atlas. It is leaving, and soon it will be just a speck of data in our archives. But its legacy is permanent. It has stress-tested our planetary defense infrastructure. It has forced the serious, if quiet, consideration of technosignatures into official discussions. It has shown us that our tools for understanding the cosmos are advancing at a breathtaking pace. 3I/Atlas is not the end of the story. It is the dramatic opening chapter. It is the universe's way of letting us know that the solar system is not a closed garden. The gate is open, and visitors are coming. The next one might not be so coy. The shield is up. The question is, are we preparing for a dialogue, or for a war we don't yet know how to fight? The silence from official channels is deafening, but the message from the data is clear. We are not alone in the cosmos, and the neighborhood is getting stranger by the day. The public story of space is one of science and exploration. The private reality, known to a select few in defense and intelligence circles, is one of vigilance and control. There is a system, an architecture most have never heard of. Those who work with it sometimes call it the deep space firewall. It is not a physical wall, but a distributed network of classified satellites, ground-based sensors, and encrypted data links. Its official purpose is space domain awareness, tracking debris and satellites to prevent collisions. Its unofficial capabilities are far more extensive. It is designed to detect, classify, and, if necessary, respond to anomalies. Anything that moves where it shouldn't. Anything that emits a signal it can't identify. Anything that behaves in a way that defies the predictable clockwork of orbital mechanics. 3I/Atlas didn't just trigger scientific curiosity. It tripped multiple alarms within the firewall. By the time 3I/Atlas approached perihelion, it had been designated a top-tier monitoring target. Defense satellites with capabilities far beyond the public's imagination were silently retasked. Their lenses, normally fixed on rival spy satellites, were now tracking the comet. The data streams from these platforms did not feed into public scientific archives. They flowed into classified servers at places like the National Air and Space Intelligence Center, NASIC, and the U.S. Space Force's Space Delta II. This creates an ethical and practical chasm. Science operates on openness. The firewall operates on secrecy. When a discovery is made, who owns the data? When an anomaly is detected by a civilian telescope, but a classified sensor has a clearer picture, who gets to decide what the public is told? We have entered an era where a comet can be simultaneously a subject of scientific study and a target of military intelligence. The protocols for this duality do not exist in any public treaty. The Outer Space Treaty of 1967 is silent on the issue of militarized observation. We are writing the rules in real time behind closed doors, and 3I/Atlas is the test case. The firewall is now active, and its very existence means we have begun to view the cosmos not just as a frontier for discovery, but as a domain for defense. The search for extraterrestrial intelligence, SETI, has traditionally listened for radio signals, a deliberate hello from the cosmos. But what if no one is broadcasting? What if all that remains, or all that is sent, are artifacts? Passive, silent, and drifting? This is the realm of technosignatures, and 3I/Atlas has plunged us headfirst into its most challenging aspects. The alien hypothesis for 3I/Atlas is not about little green men. It's about physics and chemistry. Proponents of taking the idea seriously ask a simple question. What is the more parsimonious explanation? Explanation A, natural. We are seeing a series of independent, low-probability natural miracles. A comet that formed in an extremely carbon-rich disk, that by chance acquired a mineralogy allowing for the separation of nickel from iron via a precise industrial-grade chemical process, that also has dust with extreme optical properties, and that also happened to fly on a trajectory that brought it conveniently close to Mars and Earth's orbit. Explanation B, artificial. We are looking at a manufactured object, or a fragment of one. Its composition is structured. The refined nickel is a component of its structure or a byproduct of its propulsion. Its anomalous properties are the result of design, not chance. The scientific method requires us to weigh these hypotheses against the data. The problem is our profound ignorance. We have a sample size of one technological civilization. We don't know what the signature of a million-year-old derelict probe would look like. It might not look like the USS Enterprise. It might look eerily like a weird comet. Dr. Avi Loeb's fundamental argument is that we must not assign a zero prior probability to explanation B simply because it makes us uncomfortable. To do so is not science. It is prejudice. The Keck data on the nickel is not proof, but it is a data point that is more easily explained by a technological origin than any known natural process. It is a candidate technosignature. The response to 3I/Atlas suggests that defense agencies are taking this possibility seriously. They are not waiting for a radio signal. They are actively monitoring for physical, material anomalies that could indicate the presence of technology. This shifts the entire paradigm of SETI from a passive listening exercise to an active characterization effort. The question is no longer, are we alone? But what else is out there, and how would we know if we found it? The story of 3I/Atlas is unfolding in real time. Based on the current trajectory of data and disclosure, we can project a timeline for the coming months, a schedule of potential revelation. Late October 2025, 3I/Atlas reaches perihelion. This is the moment of maximum solar heating. Will it fragment? Will new, even more bizarre outgassing events occur? All telescopes, public and private, will be watching. November 2025 to January 2026. The IAWN astrometry campaign is in full swing. The workshop for participants occurs. Internally, a consensus will begin to form. Leaks from this period will be critical. February 2026. The ESA's Jupiter Icy Moons Explorer, JUICE, spacecraft, en route to Jupiter, may perform a fortuitous flyby of 3I/Atlas's trajectory. It could analyze the residual particles in the comet's wake. providing a pristine sample of its composition. This data would be a game changer. Mid-2026. The first peer-reviewed papers from the October 2025 observations are published. Will they confirm the HCN in Mars's atmosphere? Will they show definitive proof of nickel deposition in the southern highlands? The language in these papers will be scrupulously careful, but the data will speak for itself. September 2026. The launch window for SpaceX's Mars mission opens. Starships laden with Optimus robots depart for Mars. This is the point of no return. The robots are heading directly for the regions where 3I/Atlas's chemical payload is thought to have been deposited. March-May 2027. The robots land. The digging begins. Within weeks or months, telemetry data will start streaming back about soil composition and processing efficiency. This is when the theoretical meets the physical. Will the robots' AI algorithms, as predicted, start preferentially mining nickel-rich soil because it yields water more efficiently? 2028 and beyond. This is when the real story will emerge. If the chemical feedback loop between the comet's materials and the robotic industry begins, we will see it in the manufacturing data. The materials the robots build from Martian resources will carry the isotopic and chemical fingerprints of 3I/Atlas. The critical thing to understand is that by the time the scientific community reaches a public consensus, the situation on Mars may have already evolved into something new and unpredictable. We are not just observing an experiment. We are conducting one in real time on a planetary scale with an interstellar variable. 3I/Atlas is a herald. It announces the end of one human epoch and the beginning of another. For all of history, we have been a species of one world, looking out at a distant, impersonal cosmos. We are now becoming an interplanetary species, and in doing so, we are discovering that the cosmos is not distant. It is intimate. It is interactive. It sends visitors. Our response to this first deliberate, coordinated encounter with the deeply unknown will set a precedent for centuries. Have we chosen wisely? The mobilization of the firewall, the secrecy, the defense-oriented posture, it speaks of a civilization that is fearful. It is an understandable fear, born of the recognition of our own vulnerability. But there is another path, one that runs parallel to the defense protocols. It is the path of the scientists, the engineers, the explorers who are pushing our sensors and our AI to new heights, not just to see threats, but to understand. This path is fueled by a dangerous, essential, and profoundly human commodity: curiosity. 3I/Atlas is a question mark hanging in the sky. The answer we ultimately find may be natural or it may be artificial. But the most important discovery we have already made is about ourselves. We have learned that we are now a species with a planetary defense system, with quantum eyes, and with artificial oracles. We are no longer children of a single world. We are adolescents, stepping out into a galactic neighborhood, nervously clutching our shields, but unable to suppress the burning desire to see what's behind the next door. The comet will pass. The data will be analyzed, but the threshold has been crossed. The sky is no longer a ceiling. It is an ocean, and the tides are bringing in wonders and warnings from shores we have yet to imagine. On February 9th, 2025, as 3I/Atlas was plunging into the inner solar system, instruments buried deep in the Antarctic ice detected a ghostly scream from the cosmos. The Ice Cube Neutrino Observatory registered a burst of high-energy neutrinos, particles that barely interact with matter, with energies exceeding 10 teraelectronvolts. It was an event so rare and powerful that the system initially flagged it as an instrument error. But it was real, and the timing was, at the very least, provocative. Correlation is not causation. Every scientist knows this. The universe is vast, and energetic events happen all the time. A supernova in a distant galaxy, a merging of black holes, these can easily produce such a neutrino burst. The likelihood that it was connected to a small comet 4.2 astronomical units away is infinitesimally small. And yet, when you are already tracking an object that defies all categories, the mind seeks patterns. Could there be a mechanism we haven't considered? We conceptualize planetary defense in terms of kinetic impact, a rock hitting us. But space is filled with invisible threats. Radiation, cosmic rays, charged particles. What if an interstellar object, carrying material aged by millions of years of exposure to galactic cosmic radiation, could interact with the solar wind or planetary magnetospheres in a novel, energetic way? What if its coma, rich in exotic ices and metals, created a localized region of space with unusual plasma properties? Defense planners think in terms of risk, not just probability. The most likely explanation is irrelevant if the consequences of the unlikely one are catastrophic. The neutrino burst forced a quiet but serious conversation within defense circles. Are our threat models too narrow? Are we so focused on the rock itself that we are blind to the energetic wake it might trail, or the invisible fields it might project? 3I/Atlas may not be dangerous, but it has exposed a critical vulnerability in our thinking: our failure to imagine the full spectrum of what danger from space could look like. The Fermi paradox looms over this entire story. If the universe is so vast and old, where is everybody? The Great Filter hypothesis suggests that some barrier prevents life from progressing to the stars. This filter could be behind us, we are the first, a miracle, or it could be ahead of us. 3I/Atlas presents a potential candidate for a filter: the transition from a single planet species to an interstellar aware one. This transition is not just technological. It is psychological, sociological, and political. A civilization that encounters ambiguity and responds only with fear, secrecy, and militarization may never graduate to the galactic stage. It might turn inward, building higher and higher walls until it suffocates within them. It might misinterpret a benign artifact as a threat and trigger a conflict it cannot win. Paranoia becomes its filter. Conversely, a civilization that can look at an object like 3I/Atlas and manage its fear, that can balance prudent defense with open-minded inquiry, that can integrate a shattering new reality without collapsing, that civilization might just be past one of the universe's toughest exams. Our response to 3I/Atlas is our first real-time practice run for this filter. The simultaneous activation of the deep space firewall and the global scientific campaign represents the two sides of our nature wrestling for control. The outcome of this internal struggle is far more important than determining what 3I/Atlas is made of. It will determine what we are made of, and whether we have the right stuff to become a lasting presence in a galaxy that is clearly far stranger and more active than we ever dreamed. In the gap between the official all clear and the observable military scientific mobilization, a vacuum has formed. And nature, especially human nature, abhors a vacuum. This void has been filled with a torrent of speculation, analysis, and conspiracy theories. Online forums are alight with amateur astronomers comparing orbital elements from different databases, finding minute discrepancies that suggest they are working with different data. Podcasts dissect every word of every NASA press release, analyzing the cadence of a spokesperson's voice for signs of stress or deception. This is not merely fringe activity. It is a symptom of a deep and growing crisis of trust. The institutions of science, built on a foundation of transparency and peer review, are now operating in a landscape contaminated by decades of government secrecy and official misinformation on other topics. When a scientist says, the data is undergoing calibration, a growing segment of the public hears, they are deciding what to tell us. When a defense official says, this is a routine precaution, they hear, we are preparing for an invasion. The 3I/Atlas event has become a parallax view of reality. From the official vantage point, we see an orderly scientific process. From the public's vantage point, shifted by years of eroded trust, We see obfuscation and preparation for a truth too alarming to reveal. This is the unintended consequence of the firewall approach. By operating in the shadows, even for legitimate security reasons, the authorities are training the public to distrust them. The greatest immediate damage from 3I/Atlas may not be to any satellite or planetary surface, but to the fragile contract between the governed and those who govern the flow of cosmic information. Regardless of its ultimate nature, 3I/Atlas has already irrevocably changed our future. It has injected a new set of rules into the calculus of space exploration and defense. Interstellar objects are a Tier 1 priority. No longer will they be scientific curiosities. Every future hyperbolic object will be met with the full force of our coordinated observational might from day one. A new branch of astronomy, interstellar object characterization, has just been born. The definition of planetary defense has expanded. It is no longer just about deflection. It is about comprehensive characterization to assess a full spectrum of risks, including compositional, energetic, and informational hazards. The firewall is now a permanent fixture. The race for quantum and AI dominance is on. 3I/Atlas has proven that whoever has the best sensors and the smartest algorithms will have the decisive advantage in understanding and potentially controlling the narrative around cosmic events. This is now a key front in national security. The Mars experiment is live. We are no longer just going to Mars to look for past life. We are going to conduct an unprecedented, real-time experiment in interstellar chemistry and its interaction with autonomous industry. Mars has become the laboratory for understanding our galactic environment. 3I/Atlas is receding now, a fading speck of light and a mountain of data. We may never hold a piece of it in our hands. We may argue for decades about the nickel, the CO2, and the polarization, but in a profound way, the message of 3I/Atlas is not dependent on it being natural or artificial. The message is that the universe is not static. It is not a placid museum for us to visit. It is a dynamic, interactive, and deeply weird system. It sends things our way. Some are rocks, some are ice, and some, perhaps, are things we do not yet have the words for. The comet's greatest gift to us is the gift of a question. It has forced us to look up with new eyes, not just with wonder, but with a sober, mature recognition of our place in a cosmos that is both beautiful and dangerous, knowable and deeply mysterious. We stand at the shore of the cosmic ocean. For centuries, we have been content to let the tides wash in only what they may. 3I/Atlas is the first wave that has made us realize we need to learn to swim. The next wave is coming. We don't know when or what it will bring. But because of this strange visitor from the void, we are, for the first time, truly preparing to meet it.